Hello everyone. The Earth rotates about the Sun in an elliptical orbit as shown in the figure, alright. So at which point the velocity will be maximum? So the velocity will be maximum at which point? That is the question. See, we know that the conservation of angular momentum m1 or mv1 r1 must be equal to what? mv2 r2. So mass of the planet is same. So v1 r1 I can write v2 r2. This is very important in the case of planetary motion. So even Kepler's second law, it works under conservation of angular momentum. All right. Now, one thing it is very clear, when it comes to Sun and the planet, the distance, here is the least distance. I'm just going to show it here. Here is the least distance or the minimum distance, and this side is the maximum distance. I repeat, this side is the maximum distance. So at this point, its velocity will be lesser or the least, and here the velocity will be the most. All right. And what about B and D? So this distance is equal to this distance. That's why the values will be equal. All right. So once again, velocity will be maximum at A, minimum at C. Which we call this is apogee and the perigee, or aphelion and perihelion. So the thing is, here will be the velocity least, and here the question is, where is it maximum? Maximum is at A, no doubt in that. The maximum velocity will be at A. All right. So option B for Bombay is the correct answer. Thank you. So the ratio of the radii of two planets, R1 and R2, is K. All right. So I'm just writing the information in the beginning itself. R1 by R2 is given as K. All right. So the ratio of acceleration due to gravity on them is R. So G1 by G2 is given as R. Okay, no problem. Then the ratio of the escape speed or escape velocities from them would be. So we know the formula, that is escape velocity VE1 divided by VE2 will be equal to root 2 G1 R1 divided by root 2 G2 R2. Because we know that the formula, that is root 2 GR or root 2 GR, or which is equal to root of 2 GM divided by R, or as in capital R. So here I just consider the radius of that particular where the body is actually situated. If it is on the planet surface, then the radius of the planet, or if it is actually being projected or launched from other place, then that will be the radius, okay, with respect to that point. So here I can write this is equal to root 2 cancel. What about G1 by G2? So you know that it is G1 by G2 is given as R. So it is going to be root R into R1 by R2 is going to be K. So I can just write it is root R1 by R2, that is root K. So the correct answer would be root R into K. So the correct answer is root RK or root KR. So the correct option is D. D for doctor is the correct answer. I hope you understood. Very easy question. So that's it. Thank you. So in this question, the value of acceleration due to gravity at Earth's surface is G. Its value at the center of Earth, which we assume a sphere of radius R and of uniform mass density will be. All right. The acceleration due to gravity on the surface is G, and at the center it would be 0. So the value at the center of Earth will be 0. Why? Because you know that inside the value, the G depth formula we studied, that it is G into 1 minus D by R. So if D is depth, if D becomes R, then G depth becomes 0. 1 minus 1, 0 will come. Or in other way, if you consider Earth as a perfect sphere, then what is the gravitational field at the center? You can consider. So that gravitational field, I just consider it as Ig, that is equal to minus GMR divided by R cube into R cap. This is the value actually. So here you see R is the inner radius. And what is that? R is, if R is 0, then again Ig value will be 0. So one thing it is very clear, at the center the value will be always 0, and then it is directly proportional to the inner radius inside, and outside it is inversely proportional to r square. And anyways, here the question demands only one thing, what is the value at the center, which is nothing but 0. So option B for Bombay is the correct answer. Thank you. So in this question, at sea level, the value of G minimum at, so it is 1997 question. So the poles, equator, 45 degrees south latitude, etc., etc. Okay, whatever. So the thing is, here you have to understand one thing. There are two factors. If you look very close to it, there are two factors which are affecting this G value. And one is the shape of Earth. And what the shape of Earth, what is the shape of Earth actually? In reality, in practical scenario, the shape of Earth is basically considered as shape which is a bulged shape, which is basically the radius at equator is greater than radius at poles. So basically, equator radius would be more. It is not a perfect sphere. So you can, without any doubt, you can say G equator will be less than G pole. And that is why we consider almost 9.8 at equator, then 10 value is 10 at poles. And second thing is that's what I said, if you are looking into the minute details, then there will be one more factor which is affecting, that is rotation of Earth. Rotation of Earth is also a factor. And in the case of rotation of Earth, we know the formula G omega is equal to the G on the surface without rotation minus R omega square cos square lambda, where lambda is the latitude angle. So lambda of equator will be 0, whereas lambda of pole will be 90 degree. So the cos value will be 0. So at the poles, there won't be any effect of this rotation. Gravitational difference, gravity difference wouldn't be there. But whereas at equator, it will be there. So even though the change is very small, but still, if we consider it, you will understand that the G value is minimum at equator and maximum at poles. So the correct answer is B for Bombay. I hope you understood. Thank you. So in this question, the escape velocity of a sphere of mass m is given by mass of Earth, radius of Earth, and G, gravitational constant, everything is given. The answer is, no doubt, root of 2gm by r. Because you know that escape velocity, what is the formula? How do we get it? From the surface, it is actually being escaped. It is getting escaped. So what is the total energy at this point? It has potential energy, that is minus gmm divided by r, because on the surface of Earth, plus the velocity that you're giving, that is half mv square, the kinetic energy, corresponding kinetic energy will be there. So when it reaches to infinity, let's say this is considered as infinity, what is the energy it has? Energy, total energy will be 0. So apply conservation of energy. You know that gmm divided by r is equal to half mv square, or gmm by r plus half mv square is equal to 0. That is a condition for escaping or making a body to escape. This is the idea. All right. So m got cancelled. I can take it outside. So gm by r is equal to half v square. By the way, minus sign is there. And what is v square? V square is equal to 2gm by r, or apparently v is equal to root over 2gm by r. This is the formula. Or gm is equal to gr square, you can substitute. So root 2 gr is also a correct answer. But given option is basically root of 2 gme divided by re. So just keep that in your mind. All right. Thank you. So 2000 question. For a planet having mass equal to the mass of Earth, but radius is 1/4 of it, the escape velocity of this planet will be. We know that the escape velocity formula, root of 2gm divided by r. And for this planet, the mass is same as what? This is escape velocity of the planet I'm just considering. Mass is same as what? Earth. But radius becomes 1 by 4th. So this 4 will be coming on the top. So it's going to be root 4, that is 2 into root of 2 gm divided by r. What is root 2 gm by r? So it is nothing but 2 into, that is 11.2 kilometer per second. That is for Earth. For Earth, it is nearly 11.2 kilometer per second. So the correct answer would be 22.4 kilometer per second. So the correct option is again B. B for Bombay is correct answer. I hope you understood. Thank you. So in this question, 2000 question basically. So gravitational force is required for. So the answer is convection. So in the case of convection, what is happening essentially this happens in liquids, and you know that like when you heat this particular liquid, so this temperature of the liquid, the bottom layer will be increased, and they will be like having lesser density, and volume increases and density will be lesser, and then this will go on top, and this heavier molecules which are less temperature, the hotness will be less, and they'll be coming down. All right. So this process happens only because of this is a play of weight or gravity. So cool molecules will come down and warm molecules will go up. Okay. So this is due to gravity. So essentially gravity is required for convection. I hope you understood. Very simple question. We will meet in the next one. Thank you. A body of weight 72 Newton moves from the surface of Earth at a height half of the radius of Earth. Then the gravitational force exerted on it will be. So you know that the weight will be different. Why weight will be different? Because g will be different. So what will be g at a height h? So that is g divided by 1 plus h by r the whole square. So what I'm going to do is I'm just multiplying m here. So what is m g at h? That is weight at a height h is equal to weight on the surface of Earth, weight on the surface divided by 1 plus h by r the whole square. Correct? So I'm going to do one thing here. This weight h is equal to, weight on the surface is given already, that is 72 Newton divided by 1 plus, what is h? Half of the radius of Earth, that is r by 2 divided by r get cancelled, the whole square. 1 plus 1 by 2 is 3 by 2 the whole square. So 72 Newton divided by 3 by 2 square will be 9 divided by 4. So the correct answer is 4 into 72 divided by 9. And you know that 9 and 72 you can cancel, and it is going to be 8. 8 into 4 is basically 32 Newton. So the correct answer is 32 Newton. So the option B for Bombay is correct answer. All right. Thank you.